What is microscopic material fatigue in building failure? Imagine a tiny crack forming inside a building's metal beam, invisible to the naked eye. Over time, this small flaw can grow and cause a big problem. That's what microscopic material fatigue is all about. It happens when materials like steel or concrete weaken gradually because of repeated loads. Think about bridges, skyscrapers, or even pipelines. They all face forces like wind, traffic, or temperature changes that cause tiny stresses. These stresses are often much lower than what the material can handle in a single push. But when they happen again and again, they cause tiny dislocations inside the material. These dislocations are small shifts in the arrangement of atoms or grains. They gather near surface irregularities or welds, creating tiny irregularities called slip bands. These slip bands act as starting points for microscopic cracks. Over many cycles of loading and unloading, these cracks slowly grow. The process has three main stages. First is crack initiation, where tiny cracks begin at stress concentration points like welds or bolt holes. Next is crack propagation, where the cracks extend gradually, weakening the structure. Finally, when the cracks reach a critical size, the material can no longer support the load. It then fractures suddenly, often causing a catastrophic failure. This process is especially important in building failures because structures are constantly subjected to fluctuating forces. For example, wind pressure on a tall building or vibrations from traffic can cause repeated stresses. Even if these forces are below the material's static strength, they can still cause damage over time. Detecting these tiny cracks before failure is very difficult because they are invisible without special equipment. Engineers look for signs like surface striations or beach marks on fracture surfaces after failure. To prevent such failures, designers try to minimize stress concentrators like welds and sharp corners. Regular inspections and quality control during construction, especially in welding, help catch early signs of fatigue. Environmental factors like corrosion, temperature swings, and humidity can speed up crack growth. Knowing about microscopic material fatigue helps explain why some structures fail unexpectedly despite appearing fine. It shows how tiny, invisible changes can build up over years, leading to sudden breakdowns. This knowledge guides engineers in designing safer buildings that last longer by addressing these subtle but critical damage mechanisms.